Hi, my name is Noah, and I'm a sophomore at Ohio Northern University. Over the summer, Ohio Northern University gave me the opportunity to work on a program studying natural user interfaces. Natural user interfaces are systems that allow users to control electronic devices in a way that is more intuitive, ergonomical, or ingrained than traditional systems. For example, mouse clicks are replaced by a simple swiping motion of the hand, a gesture that people already make daily. The idea is that a person will be able to control his or her computer more easily because the way they give it commands is more like the way they would interact with the real world. For my project, we studied two devices, the Microsoft Kinect 3D camera and the Emotiv Epoch brain-machine interface. We started with the Kinect. Microsoft Kinect includes several sensors. The main 3D camera consists of an infrared laser, which sends out a scattered beam of invisible infrared dots. The infrared camera can see these dots, and using an unknown method is able to calculate the distance away from the camera of every pixel in the image. This information can be used directly, but the Kinect can also use it to locate people in the image, providing data on where they are and location of various joints on their body. The Kinect also includes a color camera and directional microphone array, which can be used for speech recognition. For our first Kinect project, we decided to start simple. After studying some of the example code for the Kinect, we decided that we should be capable of writing a simple application that uses the skeletal information. We built an application that would measure the angle of the user's shoulders and determine their posture, whether they were falling to one side or another. This project was inspired by my neighbor's equine-assisted therapy horse riding program. Many riders have difficulty staying upright on the horse, so this could be used to give feedback on the instructors on the posture of riders. After that project, we decided we wanted to make a program to consume the raw depth information. So we made a program that would subtract the background from the color image. The program ran very smoothly, but as you can see, the depth information did not exactly match the color information. I believe this has to do with the difference in position of the color in our cameras and geometry. In any case, the program can be mostly fixed using a function that comes with the Kinect SDK. One of the greatest advantages of having a 3D camera is the ability to pick out multicolored objects, something that is very difficult for a color camera to do. I programmed the Kinect so that it would search a single line of the image for any object that looked round. When we placed cylinders in the Kinect's view, the Kinect was able to distinguish them from square objects, despite the fact that their color images were nearly indistinguishable. Then I programmed the Kinect to compare various 3D shapes by learning first what the shape looked like and comparing it to others. The program works by picking a single starting point and comparing every adjacent pixel. If the depth of an adjacent pixel is within a centimeter or so of the first, then that pixel is considered part of the object. As we ended the Kinect project, we decided to combine all the features of the Kinect into one program. This program uses the skeletal data to track the user's right hand, which is used as a pointer. Whatever is in the right hand is the target. When the user says Kinect target, it maps out the shape of the object and then stores a color image of it. As the user moves their hand, the object follows it around on screen. The Emotiv Epoch headset is essentially a wearable EEG machine. It has 16 sensors that contact your scalp in order to read electrical signals. The Emotiv headset can be trained to detect facial expressions, emotions, or conscious thoughts. It also includes a pair of gyroscopes to detect head motions, although we did not use this feature. The headset is fascinating to actually use. A new user must first train the system to recognize their brainwaves. They do this by associating different thoughts and feelings with the actions they want to occur. For example, to move a mouse as we did, the user may think about lifting things or the feeling of flying. When the user does not want to move the mouse, they should not be thinking about those things, but concentrating on something else or doing another activity. The amazing part of the Epoch headset is that you can interact with the world without moving a muscle. Epoch literally knows what you're thinking. The Emotiv headset proved to be more difficult to program than the Kinect. The software included with the headset handles all the work of decoding the brain signals, but actually talking to that software was harder to get used to than the Kinect. The only really successful program we made just for the Emotiv was a simple mouse emulator. The user trains the headset for two actions, one to move the mouse up and one to move it down. I was able to successfully control both actions, but the several second lag time was very frustrating. The Epoch helmet uses conductive felt pads to pick up brainwaves from the user's head. Each pad has to be dipped in a saline solution and attached to the helmet before use, then disassembled afterwards. On my head, the sensor pads became very uncomfortable after wearing the helmet for about 20 minutes. That said, the Epoch helmet is a very powerful tool because it allows programs and users insight into a very mysterious thing, the brain. Other tools such as mice, keyboards, buttons, levers, cameras, microphones, even that cool Nintendo virtual reality glove, all rely on physical manipulation. The Epoch has the potential to allow our devices to learn what we want without us learning anything about how to manipulate the device. When your brain recognizes a pattern that it is thinking about, there are certain groups of neurons that fire. Brain-machine interfaces like the Epoch could listen for those groups of neurons so that you wouldn't have to learn any gestures or commands to tell the system what you want. It already knows what you're thinking. We combine these projects to create one very interesting project. The Kinect monitors your entire body, so any movements you make change the input to the Kinect. The Emotive can read your thoughts without you making any movements. This combined program uses the Kinect to pick out a single object. Once the object is located, it is copied onto the screen, and the copy can be moved up and down using the Epoch headset, so it looks like you're levitating an object, a virtual object. Many projects have already been undertaken to study the usefulness of the Kinect and other natural user interfaces. Robotics is often a part of these studies as the control systems for robots become more and more complex. However, a majority of the applications for the Kinect and other natural user interface systems will probably be more mundane. Both the Kinect and the Epoch helmet are off-the-shelf solutions for anyone who wants to experiment with natural user interface. Both utilize technologies that may soon enable more natural interaction between people and machines.